Hello students, welcome back to the second video of this playlist. So in this playlist we are solving question paper of P4 session 2023 October. So in this question we have got a question from rates of change, specifically from differentiation chapter, that is discussed in chapter number 5 of your P4 book. Okay, so let's see what they have said in question number 2. At first, you can see a figure 1. There is a cube, right? There is a cube given which has its length of one side x centimeter. So figure 1 shows a cube which is increasing in size. Okay, at time t seconds, the length of each edge of the cube is x centimeter. The surface area of the cube is s centimeter squared. The volume of the cube is v centimeter squared cube. Okay, so given that the surface area of the cube is increasing at a constant rate of 4 centimeter squared per second, the surface area is increasing. So increasing surface area, what does it mean? The rate of change of surface area, that is ds over dt, right? ds over dt, this is given as 4 centimeter squared per second, right? Okay, so the first question, A, show that dx over dt equals to k over x, where k is a constant to be found. Fine, we need to find out dx over dt. Okay, so it's like this type of questions from rates of change is very frequent in the recent past papers. So in this type of questions, the first thing you need to keep in your mind is that we need to represent the rate of change equation in terms of the known rates of change expressions. Make sense? So here we need to find out the rate of change of x, dx over dt, right? So we need to represent dx over dt in terms of the known rates of change expressions. So what we know in this question, what are the rates of change expressions we know here? Write it first. On the screen you can see ds over dt, it is known to us, right? So let us try to represent dx over dt in terms of the known expressions, rates of change expression. So write ds over dt. Okay, now does the right hand side and left hand side become equal? No, it doesn't. So what we need to do, we need to multiply it with another known rate of change expression. So what it could be, look, we got ds on the numerator there, right? So we need to have another ds on the denominator of the second rate of change equation. Okay, and here we should have dx, so that left hand side becomes equal to the right hand side. So now the problem is, where can I get dx over ds? Because it's not given in this question, right? It's not given anywhere. So how can I figure it out? Just think a bit. What's the area of a cube? The area of a cube is what? The surface area is what? Area of one side, that is x squared, times a cube has 6 sides, right? So 6x squared, right? S equals to what we can write? 6x squared. Okay, now we can easily find ds over dx. So what we will get? 12x, right? 12x. So ds over dt times dx over ds can be written as what? 4 times, we got ds over dx, so we need to make it reciprocal. So that means 1 over 12x. So what it will be? It will be just 1 over 3x. That's it. Done. Next, part B. Show that the rate of change of volume equals to v to the power p, where p is a constant to be found. So now they are asking to find dv over dt, the rate of change of the what? Volume. So how can we find out dv over dt? That's a question, right? So exactly like as the previous question, as the previous answer, we will represent the rate of change equation, that is dv over dt, in terms of the known rates of change expressions. So let's do that. So dv over, we got dt, that would be equal to what? dv over dt would be equal to what is known to us? We know dx over dt. Can we write this? dx over dt. Okay, let's write it. dx over dt, dx over dt, but it's not getting equal to the left hand side, right? So what we can do? We can eliminate dx. Okay, we can eliminate dx. So how can we eliminate dx? Take dx in the denominator of the second rate of change equation and take dv at the top. That means we need to have dv over dx. Now the question is, why I didn't consider ds over dt? Okay, why I didn't consider ds over dt? Can we make an equation in terms of ds over dt and dx over ds? It's not possible. It's not possible because you can't make relationship between the surface area and the volume. Okay, it's not possible. That's why we didn't consider that. Okay, but we can make a relationship between the volume and the length of one side. How? The volume of a cube is what? X cube. The volume of a cube is what? V equals to x cube. So we can easily find out dv over what? dv, it would be dv over dx, right? This is what? This would be 3x squared, isn't it? Okay, now put it there. Dx over dt is what? Dx over dt, we got 1 over 3x, 1 over 3x times dv over dx is what? dv over dx is 3x squared. 3x squared. So what we can write? 3x cancels out, so you'll get just x, right? Now the question, if you see the right hand side, it wanted in the form of v to the power p, right? So what was the volume? Volume was x cube. So how can we make x in terms of v? Just write x cube there and make the power what? 1 over 3. So that 1 over 3 times 3, it will become 1 again. So we can write v to the power 1 over 3. The value for p is what? 1 over 3. Done. This was all about question number 2 from October 2023 P4 paper.